So I'm going to just throw up here all the formulas from Chapter 3. Then we're going to open it up to whatever questions from Chapter 3 you want to discuss, practice, quiz, homework. And then we'll transition into finishing up Chapter 4. Got one last section there. And just remind you guys, if you want to just keep adding formulas to your old formula sheet, just kind of make it grow, you can do that, or you can have a separate sheet for formulas for the probability quiz. Either way, you're going to turn them all in, whatever the hell you use anyway. So if you lost points on one, maybe rewrite it. I've actually had people reuse the same one, and I was like, all right, well, I already know how many points to take off. What was the basic idea behind OR? What is OR fundamentally? Yeah, it means add. OR means add. OR is the nice bouncer. More and more people can get in, right? So I'm going to add these two, but I say basically add because I might have to adjust it because maybe I counted some twice. Anybody who was both would have been counted twice. I like it. Yes. So what's and basically mean?
Multiply.
Good. And basically means multiply. It's got the little adjustment in it too. Man, both of you guys suck. Let me see. Let me try blue. So it works either way. And just to show you what this means, if I had a deck of cards and I picked two cards without replacement, you guys with me? So I picked a card and I threw it away. Would the probability I get a king and then an 8 be different from the probability I get an 8 and then a king? Would they be different? Think about it for just a second. Probably get a king and then an 8. Would that be fundamentally different somehow from getting an 8 and then a king? Would there be any reason those would be different? No. So that's why you can multiply these either order. Maybe. And then the last dude here. There's one thing, there's another thing. So the last thing is the given. What goes in the bottom of a given?
Straight line.
Oh, okay. Given is symbolized by a straight line. What goes in the bottom? Yeah, the given. And of course, if B happens, the only way that A can also happen is if it's an A that's in B. Okay, I like it. All these formulas use the same idea. The number that match what I'm looking for divided by the total. Believe it or not, they do that. And just like on the practice quiz, there's really just one problem where you actually really have to use these directly. All the other ones you don't. You guys with me? So if I give you a situation where I give you everything you need to count what's happening, you really don't have to use the formulas at all. In fact, if you try to, it will very often mess you up because you're not going to use them correctly. Okay, maybe. Not because you're bad people, but just because for certain situations it's easier not to. And we covered that. Okay. Anything else that you think should be on the formula sheet for this?
What about independent?
Oh, that's an idea, not a formula. All right, so we can talk about that in a minute, right? About what independence means, what mutual exclusive means, right? Anything else that you think should be up there that I can shoot down? Because I already know the answer is no. That's about it, right? But I just want to see if anybody had it. Sometimes I'm wrong. Okay, all right. So everybody got all these? Oh, you already have them. Let me see. Here comes somebody. Let me leave those up here. So this line divides formula sheet from not formula sheet. So let's talk about independent for a minute. 3. Here. I found it. What the hell doesn't mean for two things to be independent. So if, there's this problem, I think we looked at it last time, the problems that say the very first statement is these two are independent, right? So if I say W and F are independent events, I don't like capitalized events. If they are independent events, what does that mean is true? If they're independent, do they care about each other? No. So if one of them happens, would the other one's probability change? Does what I just said make complete sense? Think about it. If I'm going to call them independent, that must mean they don't care about each other. So if one happens, the other one don't give a shit. The technical term. Less technically, its probability will not be affected by the other one happening, right? So I have to check the effect one has on the other. If this is still what the probability of W used to be, given F, does the probability of W stay the same? Then they are independent. Please note, again, you cannot have this on the formula sheet. Right? This is formula sheet, this is not. I just want to give everybody a chance to make sure they got all these. This is an idea that you must know. I like it. Yes?
Wait, so if you had the same thing like probability of W and F, and then it equals the probability of F, it would be
So this is going to get freaky.
exclusive.
You're right. No. If the probability of W given F equals anything other than this, that means F happening affected this guy. Does that make sense? If the probability of W is not the same, once F happens, they are dependent. So that's what you do. That's what you test. So when I ask you, are these two independent? The more words you write, the more wrong you are. This is a very mathematical idea. You can't say, well, let's see, student and owns this kind of car is independent, because you can have this, you don't have to be this. No, you're wrong. You're very wrong. You have to show me the math, because it's a mathematical idea. Yes?
So would the best way to show it just do the decimals not equal to each other?
Yeah, there you go. Yeah, so if I had, has everybody got this now?
Mm-hmm.
They want it? Yes, okay. So if I calculated the probability of A and I got 0.8, and I calculate the probability of A given M and I get 0.72. Knowing that M is true, did it affect the probability of A? Yes. So to answer the question then, I would say dependent, since the probability of A does not equal the probability of A given M. 0.8 does not equal 0.72. Are there a lot of words in that answer? No, just a couple. So if you start seeing yourself write a paragraph in response to are these independent, erase. Tell yourself I'm wrong. Right? You can't reason it out. You got to look at it mathematically. So whatever M is, if I know it's true, the chances that A is true went down a bit. I like it. Yes?
Can we go over the mutually exclusive ones?
Yes, okay, I love it. So anything else about independent? Okay. So mutually exclusive. What does if the event C and what letter have I not used? The L are mutually exclusive. If that's true, what can I write down probabilistically? Ooh, I like that word. Sounds like ballistics. What can I write down as far as probability goes The probability of what is what? Do I know for sure since they're mutually exclusive? No.
Probability C and L equals 0.
Beautiful. If they're mutually exclusive, one can't also be the other. So the probability that you are one and the other is 0. That's what mutually exclusive means. You can't be both. So then the probability of C and L equals 0. So if I ask you, are this and this mutually exclusive, you just look at what the and is. Is the and 0? They are. Is the and not 0? They aren't. I like it. Do not try to see any connection between independent and mutual exclusive. Do not. Just don't. There is sort of a connection, but they are not useful to think about. Yeah. Okay. Anything else about mutual exclusive? Is that all right? Is that enough? All right. You guys are like exceptionally quiet today. This is freaking me out. All right. You're like, you're paid to talk. Shut up. We're not paid to talk. We just have to be here. Okay. All right. Anything else about probability you want to talk about? Anything from the practice quiz, the homework? We're not going to review for the whole period, but
4D on the practice quiz.
yeah. So by the time you get to 4D, you've calculated what you need for it. This is a really good place to double check. Everybody has a copy of the practice probability quiz, right? Or if you don't, you're fine without having it. Okay. So 4D asks this question. What's the probability of B given A? So what you do, when I ask you a probability question, you write the formula for what I ask you. So what is the formula for that? What goes on the bottom? The given. And then the top has to be A and B, yes. And by the time you get to 4D, you're supposed to know both of those. I tell you P of A, right? And then you calculate P of A and B.
Right.
So it is all about look at what I give you, and then look at what I ask you, write the equation if there is one, and then see, does everything work together? Do I know everything I need? Okay. Anything else about the... Yeah. 96? Oh, okay, let's see. Arise. So this is the one about Babe Ruth and Jackie Robinson, all those guys. Old baseball players. It's going to come up here eventually. It's got a big table of stuff and asks you, are these two things independent? So let me just, while this is warming up, Hank Aaron and the hit being a double. So Hank Aaron, are Hank Aaron and the hit being a double independent. That's basically what it's asking. Is it up there? Yay. They give you the table, and they ask you, are the hit being made by Hank Aaron and the hit being a double independent events? This is a beautiful example. So is it pretty cool? I gave myself some single letters for those two things, so I don't have to write so much. That's basically what math is my God, it's too many words. Let's make it simple. What do I check to see if these are independent? What must I check? Yes, and what's the only probability that actually lets one possibly affect the other one? What's the only one that has the denominator change due to one of the things having happened? I don't know. That's a weird. Is that a weird way to put that? Let me just. Okay, it's the given, right? The given, the probability of a given situation is the only one that investigates how they affect each other. So I have to check the probability of H given D. Is that the same thing as the probability of H? Or the probability of double given Hank Aaron, is that the same thing as the probability of double? Question mark. So yeah, you actually have to calculate those things, but you should be able to calculate those things. How do I calculate? In fact, look at the answers. I mean, this is a multiple choice thing, which I personally hate, but I kind of like the problem, so I just had to deal with it. You see how this is hit by Hank Aaron, hit as a double? So let me see if you guys, since this is a multiple choice. The last one makes no sense. I don't know if you guys can get this. People at home don't have a clue because they got that pointed the wrong way. The probability of H given D compared to the probability of D, that's bullshit. That has nothing to do with anything. It's not something that I have to check, right? So I can eliminate D as being an answer. This one, Hank Aaron given double the same as double. No, I can eliminate that one. So it's got to be one of these other two. So let me calculate the probability that it hit by Hank Aaron, given that it's a double. So I'm going to do this one. Is that true? And then it's going to tell me which one of those options it is. In general, if I ask you, are these independent? This is what you got to check. Compare those. Did this happening affect this guy? That's the only way to see. Is that cool? Now, is the question, how do I calculate the probability hit by Hank Aaron given a double? What do I know about it? The hit was a double. So what's going to be on the bottom? Say it again. I know it's a double. I know it's a double. So what's going to be on the bottom? How many hits could it have been? I'm not sure what you're saying. 1577 maybe?
Yeah.
Yeah. All right. You guys with me? Given that it's a double, so how many things could it be? 1577. Because I know it's a double, so it's got to be out of those 1577. And then look what I could do for myself. There's my whole universe. Let me see if I can do this for myself. There we go, John. Without flipping you guys off. So out of those 1577, how many match up with what I'm looking for, Hank Aaron? 624. Is that the same thing as the probability that it was hit by Hank Aaron? So how do you calculate just the probability it was hit by Hank Aaron? I don't know shit. So what could it be out of? No, come on, you could do better. 12,000, blah, 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 blah. I don't know anything about the hit. I don't know how much it could have, so it could have been any of the 12,000, blah, blah, blah. Out of those, I want only the ones that were hit by Hank Aaron. So it'll be this out of this. And then just see if they're the same. Just see if they're the same decimal when you divide them. If they aren't the same, it's dependent, because that means that one happening affected the other one. Okay. So what is at the base of this? I'm not going to give you a multiple choice question because I hate those, right? Never ask me if I use Scantron, because no true math teacher uses Scantron. Right? Just to shame someone like us. Like they watch my stuff. If I ask you, are A and B independent, you must check the probability of A given B versus probability of A. or the probability of B given A versus the probability of B. You want to see if one happening affects the other one. That should make complete sense about dependent, independent. Do they affect each other or not? Okay, I like it. I like my hand signals, I have no idea. Okay, all right. Anything else from homework or the practice quiz? Yes?
The practice quiz A3.
Sorry, which one?
3A.
3A. Okay. A little practice quiz is starting to get a little dated, but oh well. 2018, that's just a couple years. 33% of Americans dislike the GOP's budget plan. Right there, what would you like to call that situation that they dislike that plan? What letter would you give it? D for dislike, right? How's that? Does it make sense? Okay, maybe. So what's the probability that somebody dislikes their plan? 0.33. I like it. So what's the probability that somebody likes their plan?
0.67.
Okay. All right, that's just the groundwork, right? So the first question is, if I pick 3 Americans? So for part A, you don't have to do it this way, but I like to do it this way. How many little blank spaces would I give myself? 3. And what's going to be the operation in between them? Multiply, because I want the first guy to, where to go? To first 2 to dislike it, and the last one to like it. So it's dislike and like, and means multiply, right? So it's probably the first guy, the first 2 dislike it. What would I put in each one of these?
0.33.
And this is times. And of course the last one likes it. I like it. And remember, that's related to I don't have to make fractions for this because the population is flipping huge, right? We talked about that one last time. Yes?
Can we do 91 on the homework?
So this is a good example of the first sentence being the most important thing said. Get in there. No, come out there. I really love this thing. I might be lying. Freeze. So Y and Z are independent for 91, right? Y and Z are independent. So what can I write down about Y and Z? Y and Z are independent. There's 2 things I could write down. Of Y, okay. Probably Y equals Y given Z. I like it. They are independent, so one happening doesn't change the other one. Y don't give a shit that Z happened. Or I can write it as, what's probably Z then? It's the same thing as the probability of Z given Y. Good Lord, Jeff. Poor little Y dude. Poor little Z dude. All right. I desperately wish everybody could get this because it isn't as difficult as it seems, I guess. I don't know. If Z happens, isn't that, now that phrase right there, are you cool with me saying that? If Z happens, then I'm pointing to this because this means given Z. So I know that Z happened and the probability of Y doesn't change. So Y don't give a shit about Z. And of course the other way around. If they are independent from each other, neither one of them gives a shit about the other one. That's so beautiful. They don't give a shit about you. And then, all right, so that's what I can immediately write before I've even gotten to the question, right? Rewrite the basic addition rule. Probability of Y or Z probability of y plus the probability of z minus probability of y and z. Using the information that y and z are independent of x. Okay, I love it. So what the hell would this have to do with this? Which piece of this is related to given stuff? I love those of you that have like a solution manual. You guys rewrite this thing so bad. I love the way it's written and you don't know what the hell's going on. So it's really easy for me to tell, right? So don't do that shit. I know this is weird. I know it is. What is the formula for this? Okay. Thanks for playing. What's the formula for this piece? Yeah? Sure. And what's the probability of z given y? There you go. Right. So the probability of y or z, I could rewrite this as the probability of y plus the probability of z minus the probability of y times the probability of z. Probability of y and z is probability of y times the probability of z given y. That's a formula we know. But from the problem, I know that the probability of z given y is the same thing as the probability of z. So if they give me the probability of y, do they in part B? Yes, they give me the probability of y, right? So I can put that here and here. And then they also give me the probability of y or z. You with me? I don't know if you can tell, but I like this problem. Right? So part A just says, write the formula you're going to use. And part B says, hey, go use that formula you just wrote down. You got to do a little bit of algebra here, because how many things do you not know? There's one thing, but it shows up twice. So if you wanted to, you could put an X here. Do you know what the probability of Z is? No. So put an X there if you want to, make it look more like algebra. Or don't if you don't want to make anything look more like algebra. It's up to you. That's all I'm going to say. So if I know that two things are independent, any equation dealing with a given can be rewritten. Because if they're independent, I know these is this, right? So any givens, I can rewrite it as just the single thing. That's the idea behind this problem. That information helps me rewrite equations. Okay. Anything else from homework, practice quiz? Let me give you guys the answer key. The side with all the red writing, I decided to give you a break from my beautiful handwriting, and I did it on the computer, a little answer key. The other side is something we're going to do later today.
So why did it go up from years to that? What? Why did it go up? Maybe go up, maybe since it was 3 or 4 places. It went down. So there's no replacement. So you can do that version.
All right. So I'll give you like a minute to look that over. Let me know if you have any questions, and then we're going to get into section 4.3. Somebody tried out the tutoring center, the math study center? Yeah? Is it good?
Yeah. Another one upstairs.
What's up?
The one upstairs.
Well, upstairs, yeah. So you got the one upstairs, you got the one downstairs. It's crazy. They're both free. Crazy.
I did by myself in the library. So
Kick
I
ass.
know. I did.
Not like crazy surprised, but like 2B. The one about Butterfinger and Twix and Snickers, right? Doesn't that one make sense though? If you look, you only have one Butterfinger, so if I pick it and then eat it, and then later I want another one, that's impossible. I just ate the only one there was, right? So if I do it without replacement and there's only one of them, I can't get to. So that one coming out 0 makes sense. Okay. Not seeing any questions. We're going to keep going. Chapter, oh, yes.
Sorry. For 3C, where it says the probability that at least one life plant, why wouldn't it be, because like the other ones we just multiply like 0.33.
So here's the problem. You ready? And this is actually leading into what we're going to do today. If I want, so at least one likes the plan. And I got 3 people, right? So it could be like this, right? Is that cool? That means one likes, the first guy likes the plan. Or, somebody write like a problem. Or, maybe the second guy likes the plan. Or, maybe the last guy likes the plan. Is that all the ones that match with at least one? No, that's just one. Or maybe the first 2 like the plan. Isn't that still at least one likes it? What's at least one mean? 1, 2, or 3. Or maybe the first one and the last one. Or and you have to calculate each one of these and add them up. I would much rather. So what's the opposite of at least one likes it? None of them like it. So anytime, the opposite probability question than what you're being asked has less work to do, shit, yeah. You calculate the opposite and then you do 1 minus.